one of the core developers who work on the core protocol. I get paid by the Ethereum Foundation to develop the specifications for the execution there. I'm going to talk about MEV today. So, what is MEV? MEV is the economic value that a block producer can extract when they are constructing a block. And so when I'm talking about a block, the Ethereum protocol is divided up into blocks that happen every 12 seconds. The distributed and decentralized aspect of the Ethereum protocol is caused by the fact we change randomly who the block producer is every 12 seconds. But for that 12-second block, the block producer is king. They get to decide exactly what happens, and they can construct the block however they want. And so they can exploit that by, they can reorder transactions, which depending on how the transactions interact with each other can have an effect. They can censor transactions within their block, although obviously they might just get included in the next block. They can make up their own transactions and insert those, and they can do all of these things at once. The term MEV originally stood for minor extractable value, then we got rid of minors, turned it into proposers, but we wanted to keep the M, so it's now maximum extractable value. I just guess that people couldn't think of a better M. So where do you find MEV? By and large, MEV just doesn't happen on Bitcoin, because for MEV to happen, you need complicated and transaction types, things like decentralized exchanges, lending protocols, etc. Bitcoin, the only protocol that there is you can send something and it isn't complicated enough to be interesting. On layer 2s, we're thinking things like optimism and Arbitrum here, they have centralized sequences. So rather than the system you have on Ethereum where there's a validator, the validator is chosen, they get to do whatever they want. You have one sequencer, it's run by a centralized entity, and the centralized entity promises that that sequencer is not going to do any of these sorts of MEV exploiting strategies. They're just going to take the transactions in and they're going to put them on the block in the order they receive them. There are quite fundamental reasons why, if you don't have a centralized party, you can't do this effectively. And like all MEV is either, theoretically it has to happen in a distributed system, or you need like very fancy cryptography, which people are barely starting to develop to defeat it. On Ethereum, yes, of course it happens. And I'm only going to talk about Ethereum today. Other blockchains, generally if you have these sorts of decentralized exchanges, these sorts of complicated smart contracts, you will get MEV. Most other blockchains, I don't think have this sort of infrastructure we have on Ethereum for manipulating and capturing and exploiting MEV. And I should talk about normal society as well. Like MEV isn't unique to blockchains, like it happens in normal society. Front running is a phenomenon that happens on real exchanges where people can exploit their timing of their interaction with the market. I also just point out the legality that exploiting MEV is like, it's a legally grey area. It's not clear whether it's legal. Lots of things that happen in MEV are the equivalent things on classical exchanges in the normal world are illegal and they're just banned. So types of MEV. The first and the most simple type of MEV is front running. You have some sort of economic opportunity that can be exploited. The obvious examples are arbitrage, that there's two decentralized exchanges, the prices are different, you buy on one, you sell on the other, you make a profit. Liquidations, so there's someone, they're positioned underwater on a decentralized lending protocol, you have the opportunity to lend, you have the opportunity to liquidate them for a profit, and the first person who gets there gets the profit. And then finally you have like hacks, which are like effectively a form of MEV. So there's some mysterious sequence of things you can do that result in you making money, and the first person to do that gets the pot of money. The basic framework here is you have the first person gets here, so if you look at the example of the diagram, the first person sends a transaction succeeds, and then the other people who are trying to exploit the same opportunity, their transactions fail because the opportunity is not there anymore. And the block producer is entirely at liberty to decide what succeeds and what fails. And I'd like to point out front running is not necessarily a bad thing. Front running is doing a lot of like cleanup. So for example, the reason why prices on decentralized exchanges are accurate is because there's always bots running around who are exploiting these opportunities, sending these transactions. I think of it a bit like composting. Like, you know, the breakdown of like plant matter is, it's composting, it's turning it back into something useful. Second form is backrunning. So backrunning is someone sends a transaction, and that transaction creates an opportunity, and you put your transaction immediately afterwards to exploit that opportunity. The most common opportunities are, again, arbitrage. You know, someone sells something but they chose the wrong exchange to do it. There's now a mismatch on different decentralized exchanges, and you send a transaction immediately after theirs to exploit that opportunity. Oracle updates. So lots of these protocols, they need reliable pricing information about where these prices come from and what prices things are, so they can, for example, liquidate you if your position on a lending protocol is underwater. And those possibilities become available when the oracle, which is usually from outside Ethereum using something like Chainlink, comes in and changes the price. So you have the price change transaction, and then immediately after the price change transaction, you have all the bots who are now exploiting all the things that can happen because the oracle has been updated. And then finally you get various random situations where some buggy or suboptimal code leaves money around, and as soon as that transaction lands in the mempool, you can exploit the mempool. They can spot that, and they can like send it immediately. They can send a transaction immediately afterwards that exploits that. Like back running is just delayed front running. If you didn't do the back running in that block where the transaction originally happened, you would just send it later. It would just happen in the next block there at the same transaction happen. The example I've given here is actually a slightly unusual example. I'm using Rocket Pool. This actually happened to me. I deposited Rocket Pool validator, and my transaction was immediately back run by someone who made, I think, almost half an F off the opportunity I'd created. So the first person, they create this Rocket Pool validator, and they free up 16F of the Rocket Pool deposit pool. Because Rocket Pool, people who want to deposit, they put their money into a pool. The pool has a limited size. When you become the other part of that transaction, you create your validator, you take the 16F out of the pool, and that means that someone else can now put 16F in the pool and fill it back up again. And because the price of F, the RF you get in exchange for depositing in the pool, is greater than the value of the 16F you need to deposit, you can make money, hence why the pool is full. And I don't think anyone, when they decided to have this system, when you have the Rocket Pool protocol for staking, anticipated that by having a limited size pool, they had created a weird opportunity where people were going to play strange economic games, but they did. And finally, you have the nastiest type of attack, the sandwich attack. Sandwiching is when you simultaneously front run someone and back run someone. You have some sort of transaction where what that transaction does depends on some state that you can manipulate by sending your own transactions. The absolute classic example which I have here is the classic price one. This person here, who's the orange transaction, they want to buy some wrapped dough, so they send a transaction that says, buy the wrapped dough to the current market price from whatever decentralized exchange they feel like it. And so what happens is that the block producer grabs the transaction and they put a large wrapped Doge buy in front of the transaction and push the price way up. And then when the orange transaction comes in at buy, they don't buy at the market price, they buy at this artificially high price that this person's created by sending this transaction. And that pushes the price even higher. And then the second guy comes in, and there's a guy who comes back in, sells his wrapped Doge that he bought in the first transaction back again at the ever so slightly higher price, profiting. And the guy who, this money has been stolen from the guy in the middle, the guy who sent the orange transaction, he's got way less wrapped Doge than he would have because he's been exploited in this way. The other class that happens with this is liquidations on lending protocols. This can be really dangerous if you design your lending protocol wrong, because you might have a position that's not underwater. But if it uses a decentralized exchange as an oracle, you can pull this trick on it and liquidate a protocol that should never normally be liquidated. And you can steal money from people who made these positions in the protocol just by liquidating things at absurd and unsafe prices. I should emphasize here that the fundamental problem here is that information on the blockchain about prices and that sort of stuff is not economically safe within a block. Within a block, you can manipulate it in countless complicated ways. This wouldn't work across the boundaries of the block because the block producer of the previous block is different from the block producer of the current block, and so you couldn't have this coordination the second time to steal everything. Then we have to talk about how we're going to deal with MEV. Now you might think with MEV you'd want to get rid of it. You'd want to completely destroy it, but that's hard. So the rather surprising conclusion that people have come to is that we should democratize MEV. We should take the MEV, we can't leave it just to the elite, just to the sophisticated. We should allow everyone who's involved in validating on Ethereum should be allowed to exploit MEV to the maximal creative way possible. We particularly want everyone to be a validator, and if institutions can have validators that are more profitable because they can exploit this MEV, then everyone's going to stake for an institution. They're not going to stake for money. That's what we want. This is a bit of a philosophical question because we make it easier to extract MEV by doing this. And a lot of MEV is quite bad, in particular sandwich attacks are like downright exploitation. But the attitude that flashbots and people who create this infrastructure take is that fundamentally it's better to let everyone on a level exploit this on a level playing field rather than creating a system that's only the sophisticated infrastructure providers can do it. So the way they do it, and this is how it works post the merge, I'm not going to talk about the slightly different system before the merge, is there's a marketplace called MEV Boost, where you have these players, you have the searchers. They are people around the world who they look at the blockchain, they read transactions that are floating around the transactions pool, and they find the opportunities that they can exploit. And they see, someone sent this transaction, I can see it in the mempool when it executes, I could do this to it. And they send a sequence of instructions that says, execute these transactions in this order. If they all succeed, include them in a block. And they pay a bribe to do that to the block producer. Then you have builders. Builders just assemble all of those bundles, so that a typical block can contain several bundles from several people. And then you have relayers. Relayers, they're the heart of the system. They receive money, they receive instructions from builders on how blocks can be constructed. They're often the builders themselves. And they're like the trusted nexus because they protect the searchers from having their secret information leaked because the bundles need to be kept secret. They can't just float around in the public mempool the way transactions can. And in particular, they protect from attacks by validators. The validator, they get a bunch of bids from all the relayers they subscribe to. Those relayers, they choose the one they like and they sign the block header blind. That means they get given an instruction for how the block should work, but they don't see the transactions, they only see what's called the block header. And because they only see the block header, they have to commit and sign and choose that block before they can see any of the transactions, which means that things can't be exploited. Because there are some quite nasty trust assumptions here. And you have to make sure that MEV remains secret until it gets exploited and appears on chain. There's two reasons why. The first one is that lots of these people have come up, there's some secret information, you found an opportunity, you're offering to pay this much to get to exploit it. If someone else could see the opportunity, it could get exploited in advance and the whole system would be challenged. The second one is that in the sandwich attack case, you have an issue of dismantling sandwich bundles. So if we go back here, if you only execute, if the guy cheated and only the first half is executed, then the attacker would have bought the wrapped Doge at a much higher price. And the only reason why they want to do that is because they know that the sell is going to happen in the third transaction. But if you dismantled this bundle and only executed the first transaction, then this wouldn't work, and the attacker would just lose a whole bunch of money. So builders and relayers can steal from searchers, and searchers have to trust them. The validators can't cheat the system, so you can have a system like we do where there are relayers and the validators can subscribe whatever relayers they want, and the relayers don't have to trust the validators at all. Because by the time the relayers have signed their block and committed to the transactions, is too late. If they sign a second block, two things will happen. And the first is that the first one's been floating around for a bit at this point. By the time they see the transactions, and probably have already gained some attestations, it will probably win the race that then occurs between the two. And the second one is if you're a validator, you're not allowed to choose two blocks to go in the same slot at the same time. You will get slashed for Ethereum. As with any theoretical attack on Ethereum, someone's screwed up somewhere and it happened. This was April the 2nd. This was the attack that happened. So you have this validator, we are not going to read my numbers, this validator, and they were the proposer, they got the right to propose the block in this slot. And in that slot, there were a whole bunch of MEV opportunities. There were loads of sandwiches. I don't know, but I suspect that the validators themselves created this by sending a bunch of transactions that were sandwichable just before they knew they were going to create a block. So there were loads of sandwich opportunities to exploit. They then applied to ultrasound relay, which is one of the major relays, and they said, we will let you, they said we want a header from you. Ultrasound relay sent them a header for a block that contained all of these transactions, all of these sandwiches, and all of this MEV exploitation. And the validator did something slightly sneaky. They responded with a beacon block containing the execution layer block that was invalid, which meant that that block could never win the race because it wasn't even valid at all. It just wasn't a valid block at all. And they sent it back. And the ultrasound relay, if it had been designed properly, and this was a bug in ultrasound, the code they were playing, and most of the other relays were using at the time, they should have rejected it. But instead, they sent it to their local beacon node onto the beacon chain, and the beacon node rejected it. The beacon node said, this is an invalid block. I'm not taking that, thank you. But despite the beacon node being like, no, this is invalid, they still sent the entire block back to the validator through the MEV boost protocol, which means the validator got their hands on this block that no one else had seen with all these sandwich opportunities. And what did they do? Well, they dismantled all the sandwich opportunities, they took buys and exploited all of it themselves. And they managed to exploit an absurd amount of money. They got $20 million worth of money from these poor sandwiches who had just been trying to make a few cents of sandwich exploitation. And that was pretty crazy. Amusingly, of course, this does mean that the validator had signed two beacon blocks, one of which was comically invalid and one of which was the one made on chain. This made them liable for slashing if you told the beacon chain that this person had signed two blocks at the same time. That's invalid. So someone then went to read the logs of the software that had done this, and they were like, oh, and worked out what the block was that had been signed, reconstructed it, and submitted it as a slashing to the beacon chain, which was also the validators who'd stolen about $20 million, getting punished for signing two blocks, but being slashed for $1,975, or about one equal. It doesn't really make much difference. I should just point out for context here that, of course, all of this stuff I'm talking about is being done entirely by automated software. All of this happens within a 12-second window. There's no people who are exploiting this themselves. They're all it's all code because you don't have time to react as a human. How do you protect yourself from being exploited as an MEV person? As you usually think. Firstly, the risk of losing large amounts of money yourself to MEV-based attacks is quite low. Most of the time, there's some value that you should have received, or you could have done something more efficient. And rather than you getting the value, the validator gets the value from the MEV boosters. You're talking about doing you lose in the worst cases 5% or 0.5% or something. It's not vast sums of money. In fact, 5% would be high. The main risk is if you trade on a debt, you're at risk of being sandwiched. Most decentralized exchanges are too small to get sandwiched, because fundamentally the cost of doing all the transactions, paying the debt, and buying and selling vast amounts outweigh any profit there is to be made. And so it's quite rare as a normal end user that you will get sandwiched. The absolutely crucial thing here is that you don't fiddle with your slippage limits on the decentralized exchange. So if you go on Uniswap, there's an opportunity to edit the level of slippage, say, this is the price when I sent the transaction, I'm prepared to see up to 0.5% less, worse than that. But if it's more bad than that, I just don't want my transaction to go through at all. Yeah. If you try and change that to like say I will take 10% or I will take any price at all, you will get like nasty warnings about what we're doing. But if you do that, you will then get sandwiched and you will lose all your money. Don't do that. The big tips are use an aggregator, something like Matcha.xyz is a classic example I used to use. This, rather than just using the Uniswap DEX, it looks at all of the DEXs across the entire system, and it finds you the best price using one or maybe even multiple at the same time, depending on your transaction. Big issue here is transaction signing latency. If you're in a situation where signing is really slow because you've got some like hardware wallet and you've got some like press all the awkward buttons and type stuff and read stuff, and you spend like a couple of minutes doing that, the prices might have changed. And then like you're potentially going to be doing things that start up in prices and weird MEV stuff will happen. You can also consider outsourcing. So there's protocols like CowSwap. CowSwap, you send like a transaction detail. You sign an off-chain message. You hand it to CowSwap. CowSwap has got a complicated set of infrastructure that allows you to exploit that will like make sure that trades happen optimally. And you can use that, and then you don't have to worry about any of this. You just sign the transaction. You sign the request to CowSwap to make a transaction, and it makes a transaction for you. And then finally, you can play the MEV game, its own game. These relays, they are public. You can send whatever transactions you want to them. In particular, if you change your RPC in your wallet to rpc.flashbox.net, all of the transactions you send will go through them. They will submit it through MEV Boost as a bundle, and they get all the guarantees that searchers get. It won't be front run or back run or sandwich or whatever. And then there's Fightback. This is a very recent thing, very new. It's like amazing. There's a system called MEV Share. It takes your transaction and provides information about it to searchers. But it doesn't provide the whole transaction, particularly doesn't find the signature. So they know what the transaction you're going to send is going to do, but they don't know what it is. They can't send it themselves. They can't do it themselves. The system doesn't let them front run you or back sandwich you, so your transaction will go through the same. But they can back run you. But the rule is that if they back run you and they pay you a kickback for back running you, you get 90% of the back running kickbacks. It's now enabled by default in some limited circumstances on rpc.flashbox.net. So if you use rpc.flashbox.net, some very basic, it will really enough information to allow some very basic back running if you send a suborbital DEX transaction. You can share your entire unsigned transaction if you set your RPC endpoint to this address. Then it will give you everything, and even like weird things like rocket pool thing should go through in principle, and you should get that money. So that half an F I lost if I sent it from this system and the system existed. That back run would probably have been done to me, and I would probably have got 90% of the money opportunity that I'd created. I'm going to skip that slide. Thank you. I've been talked to. Have any questions?